Where are scalability bottlenecks most likely to occur in internet infrastructure? Have you ever wondered why sometimes the internet feels slow or unresponsive? The answer often lies in scalability bottlenecks within the infrastructure that supports our online experiences. Let's take a closer look at where these bottlenecks typically occur. One of the most common areas for bottlenecks is bandwidth. Bandwidth is the maximum amount of data that can be transmitted over a network at any given time. When the volume of data exceeds the available bandwidth, congestion happens. This is especially noticeable during peak usage times when many devices are trying to access the internet simultaneously. You can find these limitations in local access networks, internet exchange points, and even undersea cables that connect different continents. Next up are hardware limitations. Network devices such as routers, switches, and firewalls have specific capabilities. If these devices are outdated or misconfigured, they can become a bottleneck. For instance, if all the ports on a switch are in use, or if a router cannot handle the increased rate of data packets, the flow of information slows down. Network interface cards that have lower data transfer rates can also contribute to this issue. Network topology and routing are additional factors that can lead to bottlenecks. If a network is poorly designed, such as having multiple devices connected to a single switch without proper load balancing, congestion can occur. Outdated routing protocols that cannot manage many connections effectively can also create problems. Data centers and cloud infrastructure are critical points in the Internet's architecture. If the links between cloud data centers and the internet are overloaded, or if the cloud infrastructure is not scaled properly, bottlenecks can arise. This includes limitations in server processing power, storage input-output, and database performance, all of which impact the ability to handle increasing traffic and user demands. Security measures are necessary for protecting data, but they can also introduce delays. Firewalls, intrusion detection systems, and encryption requiring computational resources. If these systems are not scaled appropriately, they can slow down data flow. Lastly, latency is an important metric to monitor. Increased latency often indicates that there is congestion or overloaded equipment somewhere along the data path. This can significantly affect user experience. To sum it up, scalability bottlenecks in internet infrastructure most often occur at bandwidth-constrained links, hardware devices that reach capacity limits, inefficient network topology and routing, data center and cloud infrastructure components, and security processing that adds delays. Understanding these areas is essential for planning capacity upgrades and optimizing network design. Monitoring key metrics like bandwidth usage and latency can help identify and address these challenges effectively.